Imagine being the person at the control board of a Super Bowl halftime show, right? You hit a single button to switch cameras, and the 100-foot stadium screen just suddenly goes dead black in front of millions of people.
Oh, man. Yeah, that is the ultimate live event nightmare.
Literally the worst. But today, we're looking at the invisible engineering that ensures that, never actually happens. Welcome to the deep dive.
Yeah, to be here.
So we are pulling from a really detailed product page for HDTV Supply's WolfPack LED video processor. It's about $449. And our mission today is to extract the hidden mechanics that make those massive, glitch-free video walls at sports bars and live events possible.
Yeah, it's a small box doing a massive amount of heavy lifting.
Exactly. Okay, let's unpack this. This single piece of hardware juggles up to 8 different video inputs and 3 audio inputs at once. We're talking standard HDMI and VGA, but also like 3G SDI.
Right, which, I mean, for those who don't spend all day hanging out in broadcast booths, that's a high-speed serial digital interface. It's basically used to push uncompressed professional-grade video over really long distances.
Uncompressed, right. So you have all these dense signals flooding in, and it switches between them without a single flicker or, crash. How is it physically managing that chaotic juggling act?
Well, it relies on a protocol called seamless switching, which gives you these really clean 0 to 1.5-second fade transitions. But the real genius preventing those mid-show crashes is their pre-switching technology.
Re-switching. Okay, how does that work?
So what's fascinating here is how the system actually handles the routing. Instead of just executing a blind command to switch from, say, input A to input B, the processor actively probes input B first.
Oh, so it's checking it beforehand.
Exactly. It verifies an active sync signal. Like,
Yeah.
it mathematically confirms the data stream actually exists before it physically commits to making the switch.
Oh, wow, that makes total sense. It's not like blindly flipping a train switch and just hoping there's track ahead. It's more like a network load balancer pinging a server to ensure it's healthy before it routes any web traffic to it.
Yeah, that is a perfect analogy, yeah. It completely prevents that terrifying scenario where you switch to a dead camera feed and just project an embarrassing black square to 10,000 people.
Right, yeah. So the routing is foolproof. But making a smooth switch is one thing, right? Making it look good on a massive stadium screen is another. Here's where it gets really interesting.
Oh, the scaling, yeah.
Yeah. If this machine takes a standard HD feed and enlarges it up to, 10 times its original size, pushing outputs of over 25,600 points, shouldn't it theoretically look like a pixelated, blurry mess? I mean, you can't just stretch finite data, right?
Well, you can, unless you have some serious processing power actively filling in the gaps. The device uses dual-core 30-bit image scaling paired with an ACC and ACM image filtering engine.
Okay, wait, ACC and ACM. That's adaptive color and contrast management, right? But how does that actually prevent the image from looking like a giant blocky mosaic?
It does it through nonlinear filtering. So when you stretch an image, a basic scaler just makes the existing square pixels larger. But this engine analyzes the color values of adjacent pixels and actually calculates the missing gradients between them.
Wait, so it's creating new data?
Yeah, it mathematically generates new pixel data to smooth out the edges and restore true color fidelity. It's essentially predicting what the high-resolution version of that image should look like, and it's adjusting the brightness on the fly so it doesn't just wash out.
That is a massive amount of real-time mathematical heavy lifting just to keep those pixels sharp. But obviously, doing all that math requires constant power, which brings up another live event nightmare.
The power dropping.
Right. What happens if someone trips over a cord in the booth and the power drops? Do we just lose all those complex calculations and custom screen parameters?
Thankfully, no. They've engineered fail-safes for that exact disaster. The machine features this saved directly technology, which automatically writes every user parameter directly into the unit's EEPROM.
Right, EEPROM. That's basically a type of memory chip that physically holds onto its data even when the electrical current drops to absolute zero. Yeah.
Precisely. It's basically a hardware-level save state. So if power drops, the unit boots back up exactly as it was, like no recalibration necessary at all.
That is such a lifesaver.
Oh, absolutely. They also built in immediate crisis controls, like a one-key black button for instant screen shutoffs and a freeze function.
Oh, so you can just pause it?
Yeah, it pauses the current frame on the giant screen. That gives the operator time to frantically prep the next shot behind the scenes, and the audience never even knows. If we connect this to the bigger picture, this box really acts as the ultimate safety net for live operators. It is designed to absorb human error and environmental chaos.
So what does this all mean? Well, it means the next time you're sitting at a crowded sports bar, marveling at a massive DirecTV picture-in-picture display without a single glitch, you will know exactly what kind of invisible predictive processing is working overtime just to keep the game looking pristine.
Absolutely. And this raises an important question. With video processors now actively verifying signal health before switching and automatically generating missing pixel data to fix input errors, are we rapidly approaching a future where the live human video operator is entirely replaced by the very boxes they used to control?
I mean, that chaotic juggling act eventually managed entirely by a perfectly calm machine just talking to itself. That is definitely something to ponder the next time you're waiting for the game to come back on after a commercial break.